Welcome back. This is lesson 1.2 going over sample rates, bit depth, the Nyquist theorem, and Pro Tools system configurations. To record audio to Pro Tools, the electrical signal must be translated into digital numeric information, also known as binary data. That is the zeros and ones that your computer stores. For the process of converting analog to digital, there are two essential factors, sample rate and bit depth. Let's take a look at this waveform. Sampling is simply taking the frequency at a specific point. Each measurement, or sample, is a digital representation of the signal voltage at that instant. When you play it back in succession, these samples approximate the original signal, much like a series of still images played back in succession. The simplest way to put it, the sample rate is the frequency in which these digital measurements are collected. However, when should we collect the sample? Let's take a look at this basic sine wave being sampled at a low frequency. If you were to play it back, the original sample is completely inaccurate. The proper word for this instance would be aliasing. This is when a high-frequency signal appears as a low frequency after sampling at a sample rate that is too low. This is when the sampling theorem, aka the Nyquist theorem, comes into play. The Nyquist theorem states that in order to produce an accurate representation of a given frequency of sound, each cycle of the sound's vibration must be sampled a minimum of 2 times. If the sample rate is any lower, it will read the frequencies inaccurately. The sampling rate should be double the max frequency to ensure that all frequencies will not be aliased. However, being exactly twice can make this occur. Therefore, being slightly above double the frequency allows for a more accurate result. So, if human hearing is 20 Hz to 20 kHz, the Nyquist theorem states that we need at least 40 kHz to capture full frequency audio. However, like the example presented, the norm of recording is a sample rate of 44.1 kHz. Now, bit depth, which I personally find a bit more confusing. So, a sample rate is a sound wave cut into microslices. For each slice, the data is recorded as a value. The precision of the value is called its bit depth. Like in any computer, these values are recorded as zeros and ones. The software has a limited amount of slots for each slice, which are called bits. So if it tracks the value as 2 bits, it will only have 4 different options. However, when making a song, a normal file is 16 bits, allowing for 65,536 values. To grossly simplify it, in a sense, the higher the bit depth, the higher the quality and better accuracy for each sample measurement. Bit depth does play a role into dynamic range. To calculate a dynamic range, one must multiply the bit word size by 6. For example, an 8-bit binary word would produce a dynamic range of about 48 decibels. 16 would accommodate for 96 decibels. So what is the minimum bit depth possible? Well, if the range of speech and music is considered from 40 decibels to 105 decibels, to capture this range, an A/D converter must accurately represent differences of at least 65 decibels. Rounding up to 66 to make it divisible by 6, this means a bit depth of 11 is needed. This is why Pro Tools offers a minimum word length of 16 bits to allow for a healthy amount of headroom and accommodating a slightly wider dynamic range. When I first read this, I was confused why bit depth and sample rate couldn't be even higher. If it helps build the accuracy and quality, then why are we shying away from larger sample rates and bit depths? Well, all of these things must be stored. The higher sample rates and bit depth increase storage space exponentially. Each minute of 16-bit 44.1 kHz mono audio tracks occupy 5 megabytes of space. If we jump to 96 kHz, it is now 11 megabytes. This is only for mono tracks, as stereo files require twice as more storage space. In an unpeaceful segue, the next part of this chapter is system configurations. To record all of this information into Pro Tools, one needs an audio interface, which allows for analog to digital conversion. Here are some of Pro Tools options that is listed in the Lesson 1 of the textbook. The Pro Tools HD Omni has 2 microphone inputs, 4 line inputs, and 8 line outputs in a single space rack. The Pro Tools HD input-output is available in 8x8x8, providing 8 analog input and outputs, and 8 channels of input-outputs. There is also a 16x16 option. The Pro Tools HD MADI provides 64 channels of digital communication via coaxial and optical connections for sending and receiving digital audio streams between Pro Tools and other MADI devices. The Pro Tools MTRX is a versatile interface that delivers pristine sound via the supersonic quality of DAD's legendary AD-DA converters. It has flexible routing and monitoring control. The interface can be customized with analog and digital input-outputs. And last but not least is the Pro Tools MTRX Studio, smaller version of the MTRX interface. Lets you route any input to any output. It has a customizable monitor profile with integrated speaker tuning, and it also has a low latency. One last thing I want to cover is the ASCII characters that are incompatible with Pro Tools. When naming a Pro Tools file, you cannot use a slash, a backslash, a colon, an asterisk, a question mark, quotation mark, an apostrophe, a greater than sign, a less than sign, and a vertical slash, because LOL. Next time, I will go over the Chapter 1 review discussion questions, which should already be up. Thank you!